Next we are going to see that is 15th A question, which is highlighted in red color topics, red color text, that is for shape function for isoparametric elements, 1 dimension and 2 dimension, and serendipity elements and numerical integration. So now here 1 dimension and 2 dimension problem we already discussed in unit 2 and unit 3 and unit 4. So we already studied about that unit 2, unit 3 and unit 4. Now we are going to see only for serendipity elements. Now you may have a questions about what is the meaning of serendipity elements. So serendipity elements are represents a rectangular elements with no internal nodes. It is called as serendipity elements. So in this unit we are going to see only for rectangular element or as 4 noded elements. Okay, now see next we are going to see about isoparametric elements. So here I am going to explain what is the meaning of isoparametric elements, why we go for isoparametric elements. You can see in figure 5.1 A, it is a curved geometry. In this geometry I wanted to know about stress and strain calculation. So here I give here I apply the force in this particular area. I wanted to know about the stress in this particular area. How do you calculate? This calculation cannot be done by subject of strength of materials, design of machine element, design of transmission system. So that is why we go for FEA techniques. That is why we go for FEA techniques, that is a finite element analysis. How this process will be done? By means of dividing the how do it be done? By means of dividing the sections by means of discretization process. How do you discretization process or as meshing? In FEA software they calling as meshing. That is why I am telling as meshing. Meshing and discretization is both are same. So here it can be discretized the process. How do you be discrete? By means of triangular elements. So in see the figure 5.1b, it is here after discretization process. So you can be see the how many triangles will be there. Okay. So in this one triangular element will be calculated by one particular element. After calculating this one particular element, will be combined all the triangles. We get the solution of stress and strain, and whatever you want, you can be solved easily. Okay. So now what is the concept here? After discretization process or as after meshing, you can see there is a gap between curved boundaries and rectangular elements. Here you can see this is a incomplete process. This is incomplete meshing. So how do we solve? That is why we go for isoparametric element. So in this isoparametric element, what will do? This element is automatically merged with the means of curved shape. You can make as curved rectangular shape. How can be achieved? By means of transformation elements. That is for transformation elements. This is a transformation element. How the transformation element will be happen? By means of two definitions. First is define all the element properties directly in global system, and other one is define the elements in a simple local system and transform them to global system for calculations. So in this isoparametric unit we can go for only for second choice, that is we can be transformed, that is a local system can be transformed into global system. Now you may have a question, what is the meaning of global coordinate system and local coordinate system? Here I will explain that what is the meaning of global coordinate system. So global coordinate system or as Cartesian coordinate system. Okay, global coordinate system or as Cartesian coordinate system is both are same. For example, you can draw in ProE, CATIA and Autodesk Fusion 360. In this software you can draw the model by means of coordinate system x and y z coordinate system. Okay, without coordinate system you can't draw the model. Okay, that is called as global coordinate system. Suppose you want to make a one feature in particular point. So at the time you can change the coordinate system x and y axis and change it into some particular point. So that is called as local coordinate system. Okay, those who are working in software, you can easily understand, right? Now, so that is come into that first one, global coordinate system, or as global coordinate system or Cartesian coordinate system is corresponds to the entire body. It is represents a entire body of this system, okay, entire body, whereas local coordinate system or as natural coordinate system is represents a particular element in a body, so it is called as local coordinate system. Okay, in first case there is a no transformation required, so these where can be applied in unit 2, in unit 3 and unit 4 we can apply it only for global coordinate system. Okay, but in unit 5, for because the complex curved geometry, we go for local coordinate system and change it into isoparametric formation, that is transformation. So that is for second case. So this second case how can be achieved? By mapping of element. So that element how can be achieved? By mathematical functions. Okay, so what are the challenges here? That is involved in both rotation and shape function will be changed. How it can be changed? How do we transform the elements? The next slide we will show the how do we transform. So it is a natural coordinate system. T and S is a natural coordinate system. In some books they are referred as it is zeta and is for epsilon. Okay, so in your local author they given us it is epsilon and theta, zeta. Okay, so it is for the element, particular element, -1 1 1 minus 1 1 1 and -1 1. It is a coordinate system. So this natural coordinate system is converted into global coordinate system, that is x and y. Okay, you can the entire body it is converted, that is x and y. So here 1 and 2 and 3 and 4 it is this it is called as global coordinate system or as Cartesian coordinate system. Here T and S is a local coordinate system. How it can be achieved? By means of grid system. Okay, you can map it in the grid system by achieved by mathematical functions. Okay, that is x of x comma t and y of x comma t. So this is a transformation mapping. It is called as transformation mapping. So it is called isoparametric elements. Use the element shape function to define the coordinate mapping. Here you can see that is in this area we can be extension some distance. Okay, extension into some distance. So mapped automatically. Okay, now the second slide you can next in this slide you can see this is a parent element. Parent element is nothing but your global coordinate system. So this this particular element, that is a local element coordinate system, we can convert it into global coordinate system. You can see this is a curved shape, curved triangular elements. Okay, now the rectangular element, so it is for zeta and epsilon. So it is a local coordinate system. That local coordinate system is converted into global coordinate system by means of a quadrilateral element. It is called as quadrilateral element. You can see this particular element 7, 3 and 6. You can see this is a quadratic curve will be represent. You can see the curved representation. Once you can be changed, here also will be changing. Okay. The next you are going to see the examples of curved boundaries. So this is about that. There is elephants. So I want to know the stress and strain for this elephant, where you can, in case suppose I giving the load here in the trunk, it will be lifted the load. So at the time what will happen, the stress. So here why I am giving is, you can see the middle of the portion, it is a rectangular element. It is for the rectangular element. You can see this is for the rectangular element. The discretization or meshing is done by rectangular element. In case of the curved shape, curved boundaries, you can see the curved shape. This curved shape it can be adapted by isoparametric element. You can see here, you can see this is in this particular element only, you can be automatically curved, automatically represent the curved. You can see in these two elements, and wherever the curved shape you can see here, and also you can see in this curved shape you can adapted isoparametric element. Okay, now you can be understand. Next you are going for problems. Okay, in this problem I am going to explain one in Tamil only.